Okay, so hello everyone. What's up? Okay, so today we are going to solve unique paths 2. Okay, so yeah, I'll try to solve it, and I haven't solved this problem yet. So let's see if we can solve it. Okay, so you are given m into an integer grid. There is a robot initially located at the top left corner. Okay, so the robot tries to move to the bottom right corner. Okay, so there is basically a robot, and we have been provided with a grid with dimension m comma n. Okay, the robot can move either in down or right. Okay, so basically we can say, okay, so the robot movement, okay, movement is either right or down, right? Okay, and an obstacle and a space are marked as 1 and 0 respectively. Also, there are some obstacles in the grid, right? A path that robot text cannot include any square. That is an obstacle. Okay, so basically so we have been provided with a grid. Okay, and we have to do something. So what we have to do, return the number of possible unique paths that robot can take to reach the bottom right corner. Okay, so we have to calculate all the number of unique paths, right? So we have to return number of unique paths, right? Number of unique paths. Okay, so let's take an example test case. Okay, so we'll be provided with a grid. Okay, so let's increase the size. Okay, okay, so we will be provided with a grid. Okay. Okay, so I can say that if I have understood the question properly, I can say I will be provided with something like, let's consider a grid of size m into n. Obviously, it is not necessary that m and m are it is a square grid, right? Obviously, it is not necessary. So okay, so let's consider 4 into 3 grid, right? So considering 4 into 3 grid, we can have something like this. Okay, and 0 0 0, and again 0, and yeah, again. Okay, so so if there were no obstacle, basically the grid would look something like this, and we can easily find okay, so the robot is basically starting from the top left, right, and it wants to go to the destination, which is top right. Okay, so there are obstacles, right? Which means that let's make it obstacle, and make it obstacle as well. Which basically means that, let's say if I am standing at this point, I can either move right or I can either move down. Okay, so possibly if I am at this position, then I cannot move right, but I can move down, right? Okay, so obviously we can in order to generate all the paths, we can use recursion. From here we'll just try to go here, then try to go here, and basically it will return the number of paths going this way and number of paths going downwards. Similarly, yeah, we can do that. And obviously, okay, so but okay, since for each step we'll have in the worst case a choice of um 2, right? So it will be n square. Okay, so 2 to the power n square. Okay, so that would be exponential, right? And talking about the constants, let's see. Okay, so m and n lies between 100. Okay, so yeah, m and n lies between 100. Okay, and yeah, okay. So let's see how we can solve it. Okay, okay. So I'm sensing some kind of DP solution. Okay, so let's say if I'm starting from here, I'll have two choices. Okay, and what will I do is that from okay, so from this I'll call a recursive. I'll do a recursive call and I'll say that my object is now placed here, and I'll also do a recursive call here as well. DFS, and they will basically return the number of ways which are possible, and from this path and as well as this path. Yeah, I guess it should be possible. And there is one more thing, which is that the test cases generated so that the answer will be less than or equal to 2 into 10 to the power 9. Yeah, obviously it is important, right? Obviously it is important because there can be a situation that obviously the number of ways can exceed the limit, which is int in this case. And in that case we should either do some modulo thing, or yeah, increase it to long maybe. Yeah, I guess we can do it by recursion and try to apply memoization there. Okay, so obviously I won't be moving with this function, so I'll just create a new function. I'll say get count. Okay, path, and uh, I'll have two things. I'll have int I, which will be my index. I'll have j, and I'll have basically vector of int, and let's call it obstacle bit, right? And okay, so I'll have some base case. Okay, so what will be the choice? Let's say I'm at the index I comma j. I can either move forward or I can either move down, right? Yeah, these are the choices, right? Down or right. Okay, so I'll just say that okay, just moving right. If I am talking about moving right, I'll just first I have to check right. Yeah, I'll just call the function count path. Okay, so I'll have since I'm moving right, which basically means that I will be increasing my j, and I'll have obstacle bit, right. So it will basically return me the number of ways when I'm moving right. So right, okay, and similarly moving left, and okay, so this should return me okay, not moving left, moving bottom, right, moving down. So while moving down, I'll say my j remains constant, right? Okay, and but before this I have to check something, right? Obviously I should basically declare right and initialize with 0. Okay, yeah, I should guess, yeah. So now I'll basically return both the part which is right count plus whatever the down count is, right? And what will be the base cases, right? Obviously I know. Okay, so I should also have something called int n and int m, right? So yeah, I'll have n and m, and similarly I'll also pass n and m. So I'm considering n as the number of uh, rows, okay, and m is number of columns. So let's see, int n is equal to yeah and my bad, my m will be just right, and I'll just pass this n and m. Okay, this is okay. So what should be the base case, right? Talking about the base case, which I can think is that obviously there can be a scenario that where it moves out of bound, right? So I can say that okay. mm, um, okay. What will be the base case? Base case will be obviously that my I equals to n, and okay, my bad, and my j equals to m minus 1, which basically means that I have reached the destination. Then obviously I should return 1, right? And another base case would be obviously if I is greater than, okay, so greater than n, greater than equal to n, or g is greater than equal to n, or there can be a case where my obstacle grid I comma j equals to 1, then obviously I should return 0, right? So I guess this should be working, right? Obviously it is just a simple recursive solution, but yeah, it should work. So let's just pass, starting with 0 comma 0, I have my n, I have my m, as well as I have my obstacle grid, right? Okay, so everything looks fine, so let's see if it's working or not. Okay, what is the error? I don't know. Yeah, 34. Okay, so addition of unsigned offset. Okay, I don't know. Okay, what is the error? What was the test case? Okay, so I have get count path. Okay, I have my 0 comma 0 and n comma m, and obstacle grid. Okay, yeah, I comma j plus 1 comma j, obstacle grid, right count, down count. mm, Return 1 if I is greater than equal to n, or j is greater than equal to m, or obstacle grid I comma j equals to 1, then yeah, it should return 0, because it means that there is no path, right? So no, I don't know why it is not working. Okay, there is some issue with my get count path, right? So what is the issue? Okay, uh, I'm saying that my right count would be obviously and obstacle grid. Don't know. It should be working fine, right? Okay, runtime addition of unsigned offset. Okay, undefined behavior. Okay, so addition of unsigned offset. I don't know what does that mean basically. Okay, summary undefined behavior sanitizer. Am I accessing something that I shouldn't? What if I remove this? Is this the issue? I don't know. Okay. Okay, yeah, why I am doing I minus 1, my bad. So I should be doing I plus 1, right? Yeah, my bad. Yeah, because we are moving down. Yeah, so basically it's working fine. So the only thing which is left is that, okay, so let's say I am at this index, right? So if I'm at this index, obviously I will reach, if it is something like 0, and yeah, that's called this 0 as well, and maybe this is 1, right? So if I am at this index, then I can follow this path, right? I can go here, then go down, then go down. Okay, and I can follow this path as well. I can go down, then right, then here. So finally, which means that there are multiple ways to reach this point, right? But from this point, there is only particular number of ways to reach the end, which basically means that if I somehow know what is the number of ways to reach the end from here, let's call it maybe 22. Okay, can I say that uh, whatever the number of ways to reach 22, okay, from whichever path I'll reach 22, I'll have 22 ways to reach from here, from this point to the end, right? So which basically means that if we do it for uh, calculate it one time and just memorize it, then I guess we should be able to optimize the solution, right? So obviously the optimizing the solution is quite easy, I guess. What we can do is that let's create a global variable. Okay, let's call it a vector of, okay, vector of vector of let's call it dp, right? And I'll assign dp with and vector of int m, okay, my bad, m minus 1. Okay. So initially I'm setting it to -1, which basically means that the dp is not initialized. So yeah, so I'll say basically if dp of I comma j, these are the two states, right? If this is equals to -1, okay, this is not equal to -1, which means that obviously this uh, path has been already explored. Okay, so I can simply return the ij. Okay, I can just say, okay, when exploration is done, I can say dpij equals to, yeah. So it should be working, right? Yeah, okay. So let's test it among the sample test cases. Obviously, m and n can run between. Okay, so I cannot have empty vector, but I can have a single vector, right? So what should be the solution? Okay, so if I say something like 0, I am expecting 1, right? Okay, 0 is not a valid test case, but why? N is equals to 1, right? And n is also equals to 1. Okay, okay, let's see. Okay, obviously the number of obstacles I can't decide, it can be anything. I don't know why it is not a valid test case. Maybe I need, okay, my bad. Okay, so I can say I have something like 0, yeah, it is possible, I guess. Yeah, it's working fine. And there can be a case, right, when obviously I can't reach any. So what if, the thing which is obviously the destination or source itself is, obstacle. So I'm expecting 0, right? Yeah. So this was the case which we were missing, I guess. So, okay, so when I'm saying that, okay, I'm passing just 1, so obviously, okay, just, okay, I should not return 1. I should return 1 only if obstacle did ij equals to 0. Okay. I'm returning 1. Okay, otherwise, I am returning 0, I guess. Let's see. Yeah, I'm returning 0. That's correct, I guess. And any other test cases which should be tested. Okay, we can just do something like 1. All are, walls, right? Let's see if we can get the correct result. Yeah, we are getting the correct result. Okay, so I guess it should be correct, right? Obviously, it's a memoization. Tabulation would be more good. Okay, let's see. Okay, so it is accepted, right? Okay, so yeah, I guess we are pretty much done. Obviously, we know we can convert it into our tabulation maybe, but yeah, yeah, it's good enough. So I'll see you in next question. Okay, see ya.